Hello friends, so let us solve another interesting problem on block diagram reduction. So here there is a block diagram given and we need to find CS by ES if N of S is 0, CS by RS if N of S is 0 and CS by NS if R of S is 0. So these are the three cases. So in the first case, N of S is equal to 0. So I have N of S. So in the first case I make this equal to 0. So when this is equal to 0, then the summation does not arise. So I can remove this summation here. So therefore I would get this entire thing to be in the feedback path. So considering the feedback loop here, so if this is G of S and this is H of S, we know that the expression is G of S divided by 1 plus G of S H of S. So what do I get? We get 10 divided by S into S plus 1 divided by 1 plus the transfer function of these two multiplied 10 divided by S into S plus 1 into 0.5S. Alright. So when I simplify this, I get 10 divided by S into S plus 1. So when I multiply these two and take it to the numerator, I get S squared plus, this is 5S plus S, it gives me 6S divided by S into S plus 1. So these two get cancelled. So finally I am left with 10 divided by S squared plus 6S. So this entire thing becomes 10 divided by S squared plus 6S. So let me write that. So now this is the simplified block diagram till here. Now if you observe, I have a summer here. So now, in order to simplify this, let me shift the summer to this position. So behind S plus 4. So if I need to shift the summer behind S plus 4, so if you remember that this is S plus 4 which gets added to the output of 3. So here, if I have to shift it behind S plus 4, so now if I have to shift the summer before S plus 4, what should happen? Let's see what happens. So we have R of S and then I have the summer here and then I have S plus 4 and then we have 3. So 3 is getting multiplied with S plus 4, so I need to divide 3 by S plus 4. So the remaining part of the block diagram remains the same. So to be observed, this is E of S. Alright. So now let me consider this, the output of this summer. Let me call this as X of S. Now these two can be multiplied. So I get 10 into S plus 4. So then I can remove this block. So finally I get this block diagram. So I need to find C of S by E of S. So how do I find C of S by E of S? So let's see how this can be done. So we know that E of S is nothing but R of S minus C of S. So this is one expression. So E of S is here. So E of S is R of S, the input, minus C of S, which we get along the feedback path. Now what is C of S? C of S is nothing but X of S into the transfer function. So C of S equals X of S into, I have 10 into S plus 4 divided by S squared plus 6S. So let me call this as 1 and let me call this as 2. And what is X of S? I have X of S which is E of S plus R of S into 3 divided by S plus 4. So we have X of S equals E of S plus R of S into 3 by S plus 4. So I have these three. So I need to find C of S by E of S. So how do I get C of S by E of S? So let me substitute 2 and 1 in 3. So we observe that x of s is c of s divided by this expression. So x of s is, let me write it here, c of s. So this is x of s. So x of s is c of s divided by this expression. So I'll write it here, divided by 10 into s plus 4 divided by s square plus 6s. So this is what I get. So I have removed x of s and written x of s in terms of c of s. Now we need c of s and e of s, and I need to eliminate r of s. So what is r of s? R of s is e of s plus c of s. So r of s, so I have e of s plus this r of s is nothing but, so I have r of s here, which I am writing it as e of s plus c of s. E of s plus c of s, the whole thing into 3 divided by s plus 4. So from this expression we need c of s alone by e of s. So let me take all the c of s term to LHS. So I have c of s into s square plus 6s divided by 10 into s plus 4 minus c of s into 3 divided by s plus 4 equals e of s into 1 plus 3 divided by s plus 4. So if I simplify this, I get c of s common. So I have s square plus 6s. If I take the LCM, I get 10 into s plus 4. So this term gets multiplied by 10. That is, 3 gets multiplied by 10. So I get minus 30 equals e of s into s plus 4 plus 3 is 7 divided by s plus 4. So s plus 4 gets cancelled. So I have c of s by e of s is nothing but 10 into s plus 7 divided by s square plus 6s minus 30. And this is when n of s equals 0. Alright, so this is the first part of the problem. So we have got c of s by e of s, which is equal to this when n of s equals 0. Now I need to find c of s by r of s if n of s equals 0. Now since n of s is equal to 0, I have to reduce the block diagram and we get this expression here. Now from this block diagram, we have to find c of s by r of s. Because in both the cases, I have n of s equals 0, so therefore this representation remains the same. So let's see how we get c of s by r of s. I need to find c of s by r of s. To find c of s by r of s, I have these two summers here which are connected in succession. So when I have two summers connected, they can be interchanged. The two summing points can be interchanged by using the associative law. So I have the reduced block diagram here. The next stage, which is r of s. So I have this summer with the transfer function here, 3 divided by s plus 4 plus, and then I have the summer here, this one. So this is the simplified block diagram representation. So now this is very easy for us to simplify. So you need to remember that since the two summers are in succession, what can be done? The two summers can be interchanged or can be exchanged. So here the part is 1. So I have 1 plus 3 divided by s plus 4. Alright, so we have r of s, and this is nothing but 1 plus 3 divided by s plus 4. And then here I need to apply the feedback loop. So I have, if this is g of s, this is h of s, this is equal to 1. So we have g of s divided by 1 plus g of s h of s, because I have a negative sign here. So if I simplify that, so we have 10 into s plus 4 divided by s square plus 6s divided by 1 plus this function s plus 4 divided by s square plus 6s into 1. So finally what do I get? I get 10 into s plus 4 If I take the LCM here, I get s square plus 6s. I multiply this, I get plus 10s plus 40. So we end up getting 10 into s plus 4 divided by s square plus 16s plus 40. So this is what I write here. So C of s by R of s is multiply these two. So if I need to multiply these two, I have 10 into s plus 4 divided by s square plus 6s plus 40. I have this expression, and to this I will be multiplying this. So if I take the LCM here, I get s plus 4. So you have s plus 4 plus 3, which is s plus 7. So s plus 4 gets cancelled. So finally I get 10 into s plus 7 divided by s square plus 16s plus 40. So this is the final expression, that is C of s by R of s, if n of s is equal to 0. So if or when n of s is equal to 0. So C of s by n of s if R of s equals 0. So the third case, so let's consider the original block diagram and let's see what has to be done. So in the third case, we got to observe that we need to find C of s by, so in the third case we need to observe that we need to find C of s by n of s if R of s equals 0. Now R of s is equal to 0 here. Now if this is 0, I have 3 into 0. So this term becomes redundant and I have 0 here. So this summa also becomes redundant. So my block diagram reduces to just this. So since R of s was equal to 0, this summa can be reduced, but you need to remember that there is a negative sign here. So since there is negative, I write minus 1 here. So therefore this is the final expression, what I get. So minus 1 into s plus 4, I can write it as minus of s plus 4. So you have minus of s plus 4 here added with minus 0.5s, because we are actually adding these two, isn't it? So therefore, what is the final expression here? So we get minus s minus 4 minus 0.5s for these two, which gives us minus 1.5s minus 4. Now these two blocks can be multiplied, isn't it? So when I multiply these two, what do I get? We get minus 10 into 1.5s plus 4 divided by s into s plus 1. So this is what I have. And this goes to a summa, and then you have n of s, and then I have C of s. So let me rewrite the entire block diagram. So we need C of s by n of s. So let me put n of s here. So let me write n of s like this. So I have n of s and then a summa. And then what do I have? I have this in the feedback path, minus 10 into 1.5s plus 4 divided by s into s plus 1. And then finally you have the output, C of s. And you have a plus sign here. So now this is 1. So this is a feedback loop where g of s is 1 and h of s is this entire term. So since I have a plus sign here, the feedback path expression would be g of s divided by 1 minus g of s h of s. So let's simplify that. So the final expression, which is C of s by n of s itself, will give me 1 divided by 1 minus, because I have a plus here, minus 10 into 1.5s plus 4 divided by s into s plus 1. So since I have minus into minus, it becomes plus. If I take the LCM, you get 1 divided by, so you have s square plus s plus 15s plus 40 divided by s square plus s. So the final expression C of s by n of s is equal to s square plus s divided by s square plus 16s plus 40, and this is when R of s is equal to 0. So this was a fairly interesting problem where given a block diagram you had to find three different expressions with three different values being equal to 0, right? In the first two cases, of course, it was n of s equal to 0, and in the third case it was r of s is equal to 0. So I hope this problem has given an insight as to how block diagram simplification can be done. So in the next video segment we shall take an electric circuit and we shall draw the block diagram and finally get the transfer function. So do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and thanks for watching.